Right, so we are going to do a little bit of notes on the quadratic formula. And you guys have seen this before a long time ago in Algebra 1. You probably never saw it in geometry. And so it should be familiar to you, hopefully. And we're going to do a couple problems together. So everything that we've been doing has all been centered around doing one thing, finding solutions. And remember, when we have solutions, we're finding where our graph crosses the x-axis. We're finding zeros, intercepts, that's what we're looking for. And the thing about the quadratic formula is it's really good for finding things that are not factorable. So it's good for finding the solutions, and it cannot be used to factor. All it's going to do is give us solutions. It's going to give us those x-intercepts. And the equation, just like pretty much everything we've done this year, must be in standard form. Right? So it's got to be in that ax squared plus bx plus c form. And this is our formula. So let's talk about this formula for a second. Like my a value, that's our leading coefficient in front of x. So the a and the x are separate. You're never going to write like, if a was 4, you're never going to put like 4x under here. That's kind of a mistake I see. We're only putting numbers in here. We're solving this guy for x. And so this is our formula. You guys might have heard a song. Maybe we'll sing it next time I see you. So let's just come down here and work through a problem. You want to maybe pause the video and get a calculator, because you're going to need to be able to put this in your graphing calculator to get an answer. So this is a kind of a nice point maybe where you don't have to figure out what a times c is or anything like that. You just write your equation, you put it in your calculator, and you get an answer. And let's do this. So like our first step is we want to put this function in standard form. This is in standard form, so we don't have to worry about that. We want to identify a, b, and c. And just think, if this is in standard form, this would be ax squared plus bx plus c. That's equal to 0. So we're just comparing. There's nothing in front of my x, so I know that my a value is 1. My b value is a negative 2. You can see that. And my c value is 24. And so we're going to just plug all these values straight into our formula. And I'm not a super fan of the way this thing's typed out, but sometimes it's tough with editing programs to get everything in here. So it's negative. My formula is negative b. My b value is negative, so it's going to be a negative 2. And then it's plus or minus the square root of b squared. I'm going to highlight these parentheses. These parentheses, oops, not in blue, that's not much of a highlight color, in red. You really need to put parentheses in here for my b value. My b is negative, so it's negative 2, and we're squaring it. If you don't put your negative b in here, your b value in parentheses, and it's a negative number, when your calculator squares it, it will square it correctly, but your answer will be incorrect because it's negative 2 times negative 2. It's a big mistake I see. So now we're plugging in we've got our negative 4 times a. Well, a is 1 times c. c is 24. And that's all over 2 times a, so a is 1. We're going to substitute it into our formula. This says we're going to simplify numerator and denominator as much as possible. So let's take a look at what that means. We're going to combine like terms under here. So, excuse me. We're going to simplify. We're going to get x is equal to, we have a negative 2. That becomes positive 2. That's plus or minus. I'm going to get my line right there. Underneath my radical, we have negative 2 squared. And here's what I'm talking about when we simplify this. When we put this in our calculator, if mine will turn on, there we go. If we just do negative 2, this is going to be wrong, don't do this. If we just put negative 2 squared, it tells us it's negative 4. But we're squaring negative 2. We're multiplying negative 2 by itself. So it's negative 2 times negative 2, which gives us a 4. Or, if you're going to use exponents, you need to put your negative 2 in parentheses and then square it to get that positive 4. So negative 2 squared is 4. Minus 4 times 24. Well, negative 4 times 24 is positive 96, because that's negative 24. That's what we get, negative 24. So we're ended up with positive 96. Sorry about that. And this is all over 2. We can go one step further, and we know that 4 plus 96 is 100. So this is 2 plus or minus the square root of 100 over 2. This says write it as 2 equations, and because we're kind of back to that plus or minus thing, right? So here's what we've got. X is equal to 2 plus the square root of 100 over 2, and x is equal to 2 minus the square root of 100. It's a little bit too far, over 2. So we end up with x is equal to 2. The square root of 100 is 10, so 2 plus 10 over 2, which is 12 over 2. And so we end up with, on this first one, with x is equal to 6. That's one of our solutions. On our second one, we end up with x is equal to 2. Again, the square root of 100 is 10. 2 minus 10 over 2. 2 minus 10 is 8. Negative 8 over 2. And so x is negative 4. Those are our 2 solutions. We could think about this like maybe another way, right? So if we were to graph this thing, these give me the x-coordinates of my intercept. So we've got an x-intercept at negative 4 and an x-intercept at 6. We could use our knowledge of quadratics, and we know that my a value is positive. So this thing looks kind of like that. It opens up. And so x equals 6 and x equals negative 4. And that's our first problem, not too terrible. We're going to go to the back page and we're going to talk about something called the discriminant. And so what's happening here is we have our quadratic in standard form. The discriminant, I'm going to, just so we have it on the same page, I'm going to copy down my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And our discriminant, this discriminant, is the stuff under the radical. So my discriminant is this value b squared minus 4 times a times c. And this discriminant is pretty important. It's going to give us some interesting information, or some really nice information. It's going to tell us what kind and what type of roots we have. And when we're talking about roots, we're talking about, I'm jumping down to my graph now, we're talking about where it crosses or doesn't cross my x-axis. Those are my roots. And so we want to remember, always kind of keep in the back of your mind, that the numerical value of the discriminant is under the square root. And so we could end up with positive, we could end up with like 2 solutions, we could end up with a negative value under here, we'd have all kinds of stuff. And so basically what this says, talk about this value of the discriminant. If my numerical value of my discriminant is greater than 0, then we have, or is greater than 0, we have 2 real rational roots. Don't get wrapped up about the rational roots. That just means we're crossing the x-axis in 2 places. And we have rational and irrational. We're not going to make a big deal about that. They mean basically the same thing. An irrational root could just be like one of our roots is the square root of 2 or something like that, which is fine. Doesn't matter. So these are all the same thing. If our numerical value under the discriminant is greater than 0, we have 2 real roots. It crosses the x-axis in 2 separate places. If the numerical value of my discriminant is exactly equal to 0, we have 1 rational root. And so that means, think of this as like our perfect square trinomial, right? Like we could have, I don't know what this value is. Let's call it negative 2. But if I had x plus 2 squared was equal to 0, we can see that this has been shifted 2 units to the left. And so that gives us those roots. And kind of coming back on that again, right? If we have x is equal to, thinking about our quadratic formula, x is equal to negative b plus or minus the square root. If everything under there is 0, and then we're dividing by 2 times a, that's going to give us our one rational root, because we can't add or subtract. We can add or subtract 0 to something, but it's not going to change it. You add 0, it doesn't change. You subtract 0, it doesn't change. So we have this repeated root, right, where it touches and bounces. And then finally, if our discriminant is less than 0, we have two complex roots, and that means that we don't cross the x-axis at all. And we saw that with some of our inequalities and things that we were working with earlier. And so kind of like graphically, or not graphically but visually, if x is equal to negative b, we have plus or minus, we have some negative number under the square root. And we know if we have a negative number under the square root, we're going to have to use our complex numbers. We're going to have to use I to figure out what that is, right? Because remember, like the square root of negative 1 is I. So the square root of negative 2 would be I square roots of 2. And so that's not a real number. It's not crossing our x-axis down here. And that's what we got to keep in mind. So we're going to use this discriminant, and we're going to figure out what type of solutions and the number that they have for a couple of problems. And so the deal is, to use the discriminant, your function must be in standard form. And so remember, standard form for us is going to be, and this is equal to 0, we're solving, so it would be ax squared plus bx plus c is equal to 0. So we'll take a look at this first problem, and just so we can see it right here, our discriminant is b squared minus 4ac. I know you guys can see it on your paper. I'm assuming you can see it on your paper. So I'm going to add 3 to both sides. We want it in standard form, and we get 4x squared plus 5x plus 3 is equal to 0. And we just want to plug our values into our discriminant. So let's see, ax squared, we'll just write standard form above this, plus bx plus c. And so here's what we get. So b squared, b is 5, so it's 5 squared minus 4 times a, which is 4, and times c, which is 3. So if we work our way through this, 5 squared is 25. And then we get 4 times 4 is 16. So 16 times 3 is 48. So we have 25 minus 48. And simplify this, we end up with negative 23. So the discriminant, the numerical value of the discriminant, is a negative. And that tells me that because it's a negative, come back up to our chart, we have two complex roots. The discriminant is less than 0. We're not crossing the x-axis at all. So let's come back down here. And here's what we've got. Two complex solutions. And we can test these other two. Let's keep going. So this is in standard form, so we're just kind of plugging our numbers in. Want to be really careful with the negative 30, right? We're putting parentheses around that b value. So negative 30 squared minus 4 times a is 9 times b is 25, and we're going to simplify this. So 30 squared is 900, and then negative 4 times 9 is 36. So 36 times 25, negative 36 times 25 is negative 900. And if we simplify this, 900 minus 900 is 0. So if we go back up and look at our chart, I know that if the value of my discriminant, the numerical value, is 0, then we have one real rational root. So we touch in one spot and bounce off. So one real solution. One real solution. I want you guys to pause the video and work on this one for a minute, and then turn the video back on and check and see if you get the answer correct. And then I'll work this out. So it's not in standard form. So I need to subtract 1 from both sides. And so we get 6x squared minus 2x minus 1. This is equal to 0. We're going to plug our values into our discriminant. Again, we have a negative 2, so that's our b value. We want to make sure we put that in parentheses in our calculator. Negative 2 squared minus 4 times 6 times negative 1. And this part's, well, this part is equal to 0. We move it around. This is not really equal to 0. We're just evaluating the discriminant. So negative 2 squared would be 4. And so we've got negative 4 times 6. So negative 4 times 6 would be negative 24. But then it's negative 24 times negative 1. So that becomes plus 24. So this is equal to 28. That's a positive value. If we come back up here. So our value is greater than 0. So we have two solutions. We're crossing the x-axis in two different places. We could use the rest of the quadratic formula to figure this out, but we don't have to. We have two real solutions.